Welcome to the Hammerspace Cloud video series. I'm your host, Carla, and I'm glad you joined us. Today we are talking about Tier 0, but first, as a refresher, Hammerspace is a data platform for AI, HPC, and unstructured data that uniquely combines high-performance storage, orchestration, and mobility under a single global namespace. As we have seen from previous videos, Hammerspace uses a policy-driven data orchestration engine that can automatically move data between different storage tiers based on cost, performance, and usage policies. This episode will concentrate on Tier 0, which is the fastest storage tier designed for applications that demand ultra-low latency and maximum throughput, like AI, ML training, HPC simulations, real-time analytics, etc. Tier 0 takes advantage of storage devices in compute nodes, which can be GPU or CPU-based. Tier 0 works by automatically staging the hottest, most performance-critical data in ultra-fast storage. New writes may land in Tier 0 first, for speed, and then be migrated downstream to other tiers based on policies. Tier 0 is part of the global namespace as the performance tier. It doesn't exist as a separate storage island. Instead, it seamlessly integrates into the same unified file system. In today's episode, we will demonstrate how easy it is to configure and utilize Tier 0. We will start with an empty Hammerspace install, as well as 4 untouched application servers. Each server has one NVMe drive attached. We will use a script to configure each NVMe drive as an NFS export. Then we will use another script to attach it all to Hammerspace. Finally, we will copy over an AI ML training dataset into the Tier 0 from a separate Linux host. We start with an empty Hammerspace user interface. No storage nodes or shares have been configured. Using a Linux host that is connected to all of the application servers, we will first use a script to configure each NVMe into a NFS export. Done. To verify each export, we use the showmount-e command on each application server. Great, all looks good. Our next step is to connect all 4 of the NFS exports into Hammerspace, create a volume group out of them, and create a share that will be used as the Hammerspace Tier 0 mount. We have split the screen so the script can run on the left side, and we can see all of the steps being done on the Hammerspace user interface on the right side. Here, the NFS exports are individually being added as storage nodes. We now have 4 storage nodes and 4 volumes representing the NVMe drives. Our next step is to log into the Hammerspace CLI console and create a share that will use all 4 of these volumes. We will name the share AI Model. We have split the screen again so we can watch all the action take place on the user interface. Done. Our last step is to mount the Tier 0 storage tier on one of the application servers. We are mounting to the Anvil IP and using NFS 4.2. Let's just confirm the mount. Since Hammerspace does not use any proprietary agents, we know this will work as designed. And all looks good. We have a Tier 0 storage tier. Again, this is not a separate converged storage island. This is part of the global namespace. So let's show how easy it is to move data into the tier. On our Linux server, we have an NVIDIA Megatron GT3 language model. We simply copy it into the share, and now it's part of the global namespace. Once we are done with this AI run, we tier this data off and reuse our Tier 0 for another high-performance requirement. It's that easy. Using the Hammerspace user interface, we will confirm our AI model is there and is ready to be run. Here is a Megatron result using GPU-based application servers running Tier 0. GPU utilization over the model run was 99.98%. Here is an IOR bandwidth test using H100 nodes, again, in a Tier 0 configuration. Read bandwidth reached 1.2 terabytes per second. Tier 0 provides the speed, and the global namespace provides the transparency. Together, they make Hammerspace fast, scalable, and simple to use, so apps and users always get the right performance without worrying about where the data actually lives. Thank you for joining us, and see you next time. Please follow the link for more information.